Today we are going to learn what the rational root theorem is, also called the Rational Zero Theorem. This theorem provides us with a tool that we can use to make a list of all possible rational zeros of a polynomial function. So let's say we have the function f of x equals 2x cubed plus 3x squared plus 2x plus 3. How can we find all rational roots of this function? The first step is to list all the factors of the constant term 3, which are plus minus 1 and plus minus 3, and to list all the factors of the leading coefficient 2, which are plus minus 1 and plus minus 2. The second step is to write all the possible rational zeros as factors of the constant term over factors of the leading coefficient. So we can write plus minus 1 comma plus minus 3 over plus minus 1 comma plus minus 2, which is then plus minus 1 over plus minus 1, which is plus minus 1, plus minus 1 over plus minus 2, which is plus minus 1 half, plus minus 3 over plus minus 1, which is plus minus 3, and plus minus 3 over plus minus 2, which is plus minus 3 halves. So the possible rational zeros are plus minus 1, plus minus 1 half, plus minus 3, and plus minus 3 halves. Now, by the rational root theorem, if our function has a rational root, then it must belong to this set of numbers. And the fourth and last step we have to do is to substitute these possible roots into the function f of x to see if they are actual roots. Let's do that and start with positive 1. f of 1 equals 1 cubed is 1 times 2 is 2. 1 squared is 1 times 3 is 3. You know what? Let's do a shortcut here. 1 cubed is going to be something positive, and something positive times 2 is still something positive. The other terms are also going to be something positive. So adding up 4 positive numbers is going to be again something positive. So f of 1 does not equal 0. We are going to get the same results with 1 half, 3, and 3 halves, because all these numbers are positive. So f of 1 half does not equal 0. f of 3 does not equal 0. And f of 3 halves also does not equal 0. Let's plug in the next number, which is negative 1. f of negative 1 equals 2 times negative 1 cubed plus 3 times negative 1 squared plus 2 times negative 1 plus 3. Negative 1 cubed is negative 1 times 2 is negative 2. Negative 1 squared is 1 times 3 is 3. 2 times negative 1 is negative 2, and we keep the 3. 6 minus 4 is 2. So f of negative 1 equals 2. f of negative 1 half equals 2 times negative 1 half cubed plus 3 times negative 1 half squared plus 2 times negative 1 half plus 3. Negative 1 half cubed is negative 1 over 8 times 2 is negative 1 over 4. Negative 1 half squared is 1 over 4 times 3 is 3 over 4. 2 times negative 1 half is negative 1, and we keep the 3. 3 over 4 minus 1 over 4 is 1/2, and 2 plus 1/2 is 2 and 1/2. So f of negative 1/2 equals 2 and 1/2. F of negative 3 equals 2 times negative 3 cubed plus 3 times negative 3 squared plus 2 times negative 3 plus 3. Negative 3 cubed is negative 27 times 2 is negative 54. Negative 3 squared is 9 times 3 is 27. 2 times negative 3 is negative 6, and we keep the 3. Negative 60 plus 30 is negative 30. So f of negative 3 equals negative 30. F of negative 3/2 equals 2 times negative 3/2 cubed plus 3 times negative 3/2 squared plus 2 times negative 3/2 plus 3. Negative 3/2 cubed is negative 27 over 8 times 2 is negative 27 over 4. Negative 3/2 squared is 9 over 4 times 3 is 27 over 4. 2 times negative 3/2 is negative 3, and we keep the 3. Negative 27 over 4 and 27 over 4 cancel each other out, and negative 3 and positive 3 cancel each other out. So f of negative 3/2 equals 0. We see that the only rational root is negative 3/2. Because f of negative 3/2 equals 0. Let's do a quick recap. The possible rational zeros are the factors of the constant term divided by the factors of the leading coefficient. Not every number in this list will be a zero of the function, but every rational zero of the polynomial function will appear somewhere in the list. So substitute these possible rational zeros into the function to see if there are actual roots. Very simple. If you like my videos, like, share and subscribe. Thanks for watching and happy learning, everyone.